graphical representation of derivative. The graph of f of x is broken into several intervals. The first interval is from a to b, and then from b to c, and then from c to d, and then at x equals to b and x equals to c, x equals to b, we reach to the top of the mountain, and x equals to c, we reach to the bottom of the mountain. I want you to tell me the characteristic of the slope at each interval. So from a to b, do you see that the curve is going up? And then on the curve, I drew some tangent line. So from A to B, the tangent line is going up, going up, going up. At the moment you reach to B, the tangent line is horizontal. I will explain why in a minute. So for this kind of problem, imagine you are riding a roller coaster from point A to point D. And then at x equals to this value, here is the position of the roller coaster. When x is equals to this value, here is the position of the roller coaster. And when x is equals to this value, here is the position of the roller coaster. When x is equals to b, the position of the roller coaster is completely horizontal, and then start going downhill a little bit, going downhill really fast, and then reach to the bottom. So the position is horizontal again, and then go back up. So for the first interval, when x is between a and b, what is the slope look like? The slope is going upward, right? I will match the color and say the slope is going upward or uphill. So going upward, and the slope is positive. So from the beginning, it goes up like that. It's very steep. And then as you reach to the top, as the roller coaster is getting closer and closer to the top, the position is start getting look like this, right? So less steep and less steep. And then eventually, the roller coaster will reach to a horizontal tangent. All right. And then from B to C, the roller coaster start rolling. So at the top of the mountain, the roller coaster will start rolling, right? And then going straight down, and everyone is screaming. So the roller coaster will start going. So I will write this down first. So downward. The slope is negative. The roller coaster goes like this. So go down a little bit, and then go down faster, and then go down really, really fast, and then everybody is screaming until when you reach to C, the roller coaster will calm down a little bit because we are rolling to the bottom of the mountain, right? So, and then the roller coaster will go down a little bit, and then eventually it will reach to a horizontal tangent line. And then from C to D, it's going up. The slope is positive. It will start by going up a little bit, and then going up more, and then getting steeper. Right? What happened when x equals to b and c? So when x is equals to b and when x equals to c, we have a horizontal tangent line. What is the slope of the horizontal tangent line? The slope is equals to 0. So let me give you an example. The best way to think about this is think about the parabola f of x equals to x squared. So when x is equals to 0, f of 0 is equals to 0, right? And then we have a point at 0, 0. And then what is the slope of the parabola at this point? So f prime of x, I will just give you the first derivative. So that is a 2x. Don't worry about how I got it. Don't worry about the limit definition of derivative. I will just give you the derivative. And then when x is equals to 0, and then this is 2 times 0 equals to 0. So this 0 means the slope is equals to 0. And then you draw a parabola. 0, 0 is at the vertex. And then at this point, there is a horizontal tangent. At 0, 0. All right, and then another way to think about this is you can think about this using the concept of average velocity. Okay, so the concept of average velocity, you are at the top of the mountain, which is right over here, right? So there is a horizontal tangent at this point. There is a horizontal tangent. The slope is equals to 0. And then how about this? We add h steps forward. So we add h steps forward, and then we reach to this point, and then you can draw the rise over run, as you can see, when you do the rise over run, for the rise, is the rise big or small? The rise is very small, right? So this is very small divided by a run. So what happened when you do this? The rise is so small divided by a run. So when you have a small number, so let's say 0.000001, and then divided by 2, and then the quotient is very close to 0. As the result, the slope is very close to 0. So that is how you think about this using the secant line, or you can say using the concept of average velocity. All right, so that's it for this video. In the next couple videos, I will give you a function f. I will give you the graph of f of x, and then I will show you how to use f of x to sketch f prime of x. You don't know what the function is. You get a graph, f. I will show you how to sketch f prime of x. All right, I will see you over there. If you like this video, give me a thumbs up. Signing out.